All right, hello again. This is Jeff Scott of Blackhawk Technical College. I've been going through the first 17 chapters from the iOS 9 App Development Essentials text for the 152-153 Mobile Web Development iOS class for the spring 2016 semester at BTC. So far, I've gone over the first 11 chapters, and Chapter 12, which starts in your book on page 93, is an introduction to Swift subclassing and extensions. All right, so they talk about things in here, more talk about classes. They also talk about inheritance and about subclasses, which we'll see. There is an inheritance example in here, but I did want to mention before we go too much further that I brought my program back up, and hopefully you can see this. There are no errors over here anymore, that I can see at least. And the main reason that there are no errors over here anymore is previously I had here class bank account, and afterwards I had a colon UI view, which meant that it inherited from UI view. And for some reason, UI view must have an init in it, and since I put in a init in my file, once it saw the UI views init, it was looking for the original from, once I put a UI view in the bank account class, it was looking for the UI view init. So it was goofed up. How's that? I'm looking right there. It says expressions are not allowed at the top level. So it still might have some problems. Yeah, it still doesn't like this stuff down here. So don't think I can put this stuff up higher on it. That doesn't make any sense to do that. And I think I'm still going to get the exact same errors, and I do. All right. Maybe we'll be able to figure out the problem with that once we get to this point. Okay. But if you notice, it's only once I create, so I'm able to create these, okay. So if I remove these two lines, I now have no errors in here. All right, so I am able to create an existence of a bank account class and grab the balance from there. Okay, so jumping back into our book, section 12.1, as it says, the concept of inheritance brings a real-world view to programming. It allows what we define for one class, methods and properties, to be used in other classes. So as mentioned here, by deriving this, we're creating a type of class hierarchy. So the class at the top is known as the base or root class, and the child classes are known as derived or subclasses. Parent class is sometimes also known as a superclass. All right. Well, when you think about it, we've got a good example here that we can use with inheritance. As they start talking about in the bottom of page 93, it says really the subject of inheritance really in Swift or in any programming language is best explained by showing an example. So they mentioned we previously went in and we created this bank account class, and this is the same one that you saw that I had. And they mention, they mention here, it says, that this is a somewhat simplistic, or as they call it, rudimentary class. And when you think about it, if that doesn't make any sense, I believe at least what the author is saying about this is really it does what you do to create some kind of a new bank account. In other words, set up an account number and a balance. But it's actually too generic in its current form to do much of anything else. You know, I've used this example before that if I walk into a bank and say I want to open up an account, they're probably going to say, yes, can I help you? You know, what kind of account would you like to open up? A savings account or a checking account, etc. And that's what the author is talking about here on page 94. A savings account will need to hold an account number and a current balance. So we could create another account, another class called savings account. We could just copy all this stuff into it. It'd be kind of silly because it'd be a lot of duplication when there's really no reason to do that. So what we can do instead is we can create a savings account class, and that savings account class can come in and immediately inherit from our bank account class. So we've got this class right here. Let's do a file save. All right, I'm going to come in here and do another file, new file. You've seen this before. Go to Cocoa Touch class, go to next, and now we're going to call this savings account. Now I don't know if I can set this up so it has no subclass, but I'm going to try that. See, it doesn't want to let me go on. It wants something there. So I'll just keep it as UI view, and then I'll remove that in just a minute. All right. And it's going to create the class for us. It tells us where do you want it. We want it in our bank account example folder, and there it is. All right. But again, we don't want this to be a subclass of UI view. Instead, we want this to be a subclass of bank account. Whoops. And you'll see that the IntelliSense picked that up. All right. So now I can come in here and I can add things like are shown in the book, starting on the bottom of page 94, where we say interest rate, and we'll set that up as a float, and we'll say that it's equal to 0.0. Again, I'm just taking all the stuff that's in the book. All right. And we'll have a function for calculating interest, which will not require any parameters and which will return a float, and will return our interest rate times our account balance, which makes sense because that would be the amount of interest you've earned in the current period or whatever it is. All right. So turning up to page 95, as the author mentions here, when using inheritance, it is not unusual to find a method in the parent class that does almost what you need, but requires at least some modification. But it's also possible that you've got a method that you inherit that describes exactly what you want to do, but it's not at all written in the way that you want to use it. All right. They mention that one option in this scenario would be to ignore the inherited method and write a new one with an entirely new name, but then you've got a method that's in there that you're not using for any reason, which is a waste. So the better option, is mentioned on the top of page 95, is to override the inherited method and write a new version of it. Now they do mention near the top of page 95 there are two rules that must be obeyed when you override a method. First, the overriding method in the subclass must take exactly the same number and type of parameters as the overridden method in the parent class. So you notice we don't have any parameters there, but if we did and we wanted to overwrite this someplace else, it would have to look exactly the same in there. Secondly, the new method must have the exact same return type as the old method, or parent method. So to do this, we can come in here, we've got our stuff, we've calculated our interest, but we want to come in here and we want to have a new display balance, but we want to override the existing display balance. So I'm going to say override func display balance, and you notice it filled in a bunch of stuff for me here. And I just want to print and you see that it's realizing or recognizing this information. And now we can add something new to it. So there's a couple important points here. All right. The first is you'll notice that we use the word override because we said we wanted to override or declare a new version of the display balance. So that's the first thing. Second thing, I believe that the stuff that's in here is virtually identical to what we had earlier. All right. So we're just rewriting this. Does it really make sense to rewrite it? Well, we can. All right, we can, but we'd be better off, let me just comment this out, instead of rewriting those, to just call the parent. So I can say here, super dot display balance, which means call the parent, which will do those two lines that I just commented out, and then we can have our new interest rate. Now, as mentioned here on page 96 in the book, as the savings account currently stands, it inherits the initializer method from the parent, which we set up earlier as saying we had to pass in a number representing our account number and a float representing our account balance. All right, this method takes the steps to initialize both the account number and the balance properties. But remember that the savings account also has an interest rate variable in it. So in other words, the savings account needs its own initializer to ensure that the interest rate is properly initialized when you create an instance of the class. All right, so we want to come in here and we want to write, even before our calc interest, right after our variable here, we want to write our init method. And again, what you're going to notice here in just a second is Swift again does something differently here. So this is different than what we've looked at in other languages. The method performs its task. In other words, it performs its task on the interest rate. Then it makes a call to the init method of the parent class. In Java, for example, what we learned is that you must reverse those, and you must do the super first before you do anything else. Here, that's not the case. And the author even mentions halfway down on page 96, to avoid potential initialization problems, the init method of the superclass must always be called after the initialization tasks for the subclass have been completed. All right, so they ask us to come down here, and again, in fact, what I'm going to do is I'm going to go back to our bank account example. Our bank account.swift, and where I've created this right here. Now, I don't want to. I'll just comment this out. All right, so they're both commented out. That should be okay. So let's save that. All right, and I'm going to go back then to the savings account.swift class. Okay? All right, now I want to come down here and we're going to say var savings 1 equal savings account. And remember, it needs a number And it's getting that basically from the parent, 311. The balance, which it'll also be getting from the parent, $600. And a rate, which is 7%. This is what they use in the book. I don't know any place it'll give you a 7% rate, but you get the idea. So far, so good, no errors. Print savings 1 dot calculate interest. And we're going to need another paren there. And I'm still getting that message here, and it's probably the same error that I was getting before. Expressions are not allowed at the top level. So, and savings 1 dot display balance. And again, even though these aren't working, the good news is what you can see there is that they're being recognized. All right. All right, now mentioned on the bottom of page 96 and all of page 97, they say that another way that you can add new functionality to a Swift class is by using an extension, which can be used to add methods, initializers, computed properties, and subscripts to any existing class without the need to create and reference a subclass. So they give an example here. And they mention that when you do that, you say extension followed by the name of the class, then you add the new features. The example that's given in the book here on page 97 is shown right here. So the author says, for the purposes of this example here, all right, he said, let's assume that we need some additional properties for our standard double class. One that returns whatever number we passed in squared, and one that returns whatever we passed in cubed. So we say extension double. So we're extending an existing class. Then inside of the curly braces, we add methods or anything else that we need to do the extending. So here we added 2 new computed properties. All right, and as mentioned, now we can do this. All right, so double equals 3.0, and if we print that value squared, that should be returning 9. So as mentioned, down towards the bottom of the page here, extensions provide a quick, some would say a down and dirty kind of way to extend the functionality of a class without needing to use subclasses. All right, that said, as mentioned there, subclasses have advantages over extensions. It is not possible, for example, to override the existing functionality of a class using an extension. Also, extensions cannot contain stored properties. So this chapter was meant to add a little bit more to your repertoire as far as what you understand about inheritance. We're going to come back in the next chapter shortly and go over working with arrays and dictionary collections in Swift. So I'll be back with that presentation shortly.